This is, by the way, not intended to be negative for developers. I don't mean to because I think it's pretty good that they're able to get this line despite all the changes in development, all the new technologies, all the new tools they're having, all the new languages they have to learn. But this is a challenge. It means if we don't do better at testing, we'll get TV sets out of the market. That's twice as much defects. So you press your button off and reboot your software, right? You don't want that. It's also about, we don't have all the time in the world, high time to market, there's pressure, deadlines, more and more important, competition. So there is a need, you might say, for very effective testing on one hand. On the other hand, testing takes quite a large percentage of project cost. 30–40% at least. Talk about component testing, integration system, UAT testing. And exactly this problem is what risk-based testing is about. It talks about how to test effectiveness, addressing the things that really matter, and how to be efficient. What I mean by that is, please don't waste effort testing parts that are not that essential. So without doing a good risk assessment up front, you do great testing. Wow, I do exploratory testing. Wow, great. And I do cost-effect graphing. Wow, great. But in the wrong areas. Doesn't make sense, does it? So this is very vital for a project. And that's what we're going to discuss today. I'm going to teach you a method being used by many companies. I'll show you what companies that are using it. Hopefully solving, or at least contributing to solving this problem. So, in discussing risk-based testing, at least one slide on what's a risk. The definition is ICB. A factor that could result in a future negative consequence, expressed as impact and likelihood. I tend to say this, I would say in plain English, what it means is, if something happens, you are less happy. And sometimes that means you cannot sleep for a week, that's a big risk. Right? You're less happy, you go, oh no, God, what can we do about it? That's a big risk. And sometimes about, oh yeah, too bad, small risk. That's a risk basically. If that happens, you are less happy. Less happy could mean financial consequences, could have safety consequences, depends. As already said, we'll look at impact. So what does it mean for us? And what's the likelihood? What are the chances for it? Now, this is an important one. I used to run a company, a testing company, having about 4 people employed. And quite a few people in that company felt, when they were in a project, doing risk-based testing, doing testing, if there were still risks outstanding, oh no, we cannot go in production because all these risks are outstanding. What it meant is that they felt that this is probably a tester, they have a heart here somewhere. I think here, this guy, this is heart. Yeah. And the heart of a tester has quality. We want quality. We want to mitigate all the risks. That's who we are. I mean, that's okay. That's who we are. But I think what's important to understand as a tester, we are not the persons responsible for the quality of the system. Our job, and this is our job, and we should do it well, is to find these risks. That's our job, that's responsibility. And inform the stakeholders about the risk. And if the stakeholder says, well, I heard the risk, thank you very much, Eric, but I don't care about them, well, that's his job. It's not my problem anymore. But it's difficult, right? Because you want to, no, but you can't do that. You can't go on production. I will. That's a difficult balance always. It also means that you need to understand, if you're a tester, in what type of project are you involved in. Sometimes there are projects where taking a risk is part of the project. We need to be the first in the market for several reasons. And that means we will go live even knowing there are some defects left. And in some markets that's possible, it's okay. And we'll fix the defects later. A very risk attitude. Some markets, it's the opposite. We will not go into defect in healthcare, safety first. So it helps to understand this whole balancing act. What's the attitude of management towards risks? When we talk about risk, by the way, there are two types of risks. We've got project risks, or test project risks sometimes. Things like we don't have the right skills, we need more testers, we don't have training, oh yeah, the requirements are not very good, what about component testing? Project risks, which a project manager, or perhaps a test manager should act on. We have product risks, which have to do with what are we testing? A risk directly related to the test object, and today it's about this risk. That's what we're talking about. The other one's not important as well, eh? Don't get me wrong, but that's another tutorial. This one, okay? Of course, both usually are then documented in a test plan. You've got test plans. We're talking about product risks today, the system risks, if you want. The two test principles, which are at heart, I think, on what we're doing today. Who, by the way, did ISQ Foundation? Who have done ISQ Foundation course? Anyone? Certification course? 1, 2. Oh, all of a sudden more? Yeah? Okay. 1, 2, 3, 4, 5, 6, 7. Okay, quite a few. The first principle, which is in there, is you cannot test everything. Exhaustive testing is not possible. Because if it was possible to test everything, we will not do risk based testing, because you say, oh, here's the test design technique, state position, hang on, test it and you're done. So testing everything is not possible. Mr. Myers, I don't know if you heard about him, Glenford Myers wrote a book, I think in 1979, that's way back. It's called The Art of Software Testing. And in that book he had a little bit of code to show. And there was a do loop around the code, which could either depend on parameters once or twice, maximum of 10 times. And he showed already that actually there are 1, 2, 3, 4, 5 parts you can test. Okay, in this case. However, you can go around once, twice, 3 to the maximum of 7 times, and they're independent paths. So actually, if you want to test this little program, which I think is a 20-line program, fully, with 100% coverage on every possible combination, you require 5 to the power of 10 test cases, which is 9,762. No one will do that, of course. The only thing, the purpose of having a statement there is that it shows you that whatever discussion you have, it's never possible to have everything. We will be very happy probably for this one to say, oh, we'll do it once a day at least, we'll have 5 test cases. That's good enough. 5 compared to 9 million, it's a difference, right? So testing is always about setting priorities. I've been in the testing field for 25 years, wow. Something like that, I think. And this is a challenge we have. This is also the fun, I think. It's never the same. You come on a project, you start off looking at a project, and all of a sudden you hear there's a deadline, and these are the resources. Good luck. So testing is all about risk management. That's what we're talking about today. It's a balancing act. The most, I like that word, the most feasible coverage, the best coverage we can get. Because we have limited time. We only have so many testers. We have so much knowledge only. We have sometimes don't have the right infrastructure to do all the testing we want, right? Portability testing. Yeah, I don't have these environments. Well, that's it. That's okay. That's okay. So, what we're trying to achieve today is provide you with a method to say, okay, by looking at the risks, by analyzing those, we will get the right level. So many test cases. On those places that really matter. And the right type. By time I mean, do we need usability tests? Or do we need performance tests? Or reliability tests? It depends, of course. And hopefully also at the right time. At the right time I mean, suppose something is very, very important. And I have so many test cases for this. I would recommend, if possible, to test that as one of the first things. This statement, these slides, whether it's V-model or Agile or any other method you're using, it's always there. Whether it's a sprint of 4 weeks or a project of 6 months, there's a deadline, there's limited resources, there's limitations, and you got to do the best you can. As testers, as developers, together. The second principle we're using today is that defects are not randomly distributed in the system. Defects are very social creatures. They like to get, oh, this is a nice place. And they all sit in the same place. We've learned it over the years. It's not like there's one here, there's one there, and there's one there, and there's one there. That's not how defects are. They're like, whoa, all of a sudden there are 10 there, sitting together. And there's only 2 there. Now the only problem is we need to find out where are they sitting. Oh, there's over there. So defect clustering is very important. So what we need to do is look at our experiences from the past and say, okay, this is a system. What could be factors, what could be reasons why we have some defects somewhere? For instance, we know from past, if there are interfaces between 2 systems, interfaces means project A has to talk to project B, communication. Quite often that's a problem. And there are more of these factors around. So it means learning from our own experiences, thinking about it, and trying to find out where are these defects. It also means, if you're in a larger project that runs for a number of months, for instance, sometimes a number of years, that you can learn in the project. Because you find out the interface is actually quite well here. But the software we get from India, that's a risk factor, so it can change. And if you're in an Agile project, that's even better, because every 4 weeks or 2 weeks, you get a new release, you've tested it 4 weeks or 2 weeks. Hey, what have we learned? Where have we found the defects? And you can optimize. So this is an important slide. I'm trying to say here also is that risk-based testing or risk analysis is not a one-off exercise. It's not like in the beginning of a project, I will do a risk assessment, and I've been to Eric, so I do PRISMA, which is very good. Bang, and I'm done. So next 6 months, I never look at it. No. 2 weeks later or 3, you look at it again. Well, it's still valid. You tune.